So thank you everyone for joining us today for the next event in our webinar series with the Global Business Club. So this event is focused on opportunities and updates in AI and machine learning in advanced manufacturing. Today we have 4 featured speakers, including Pavan Muzamdar, Charles Elwood, Xiaoming Liao, and Jaron Bass. So to tell a bit about our center, the International Business Center has been designated since 1990 as a national resource by the U.S. Department of Education. We are one of about 15 different designated CIBERs across the country. The IBC has been serving the international business community for 30 years as a CIBER. And our general mission is to provide superior education, research, and assistance to businesses, public policymakers, academics, and students on international business and trade. So as mentioned, this event is part of our Global Business Club series. And the Global Business Club, our main mission is to serve as a bridge linking Michigan exporters and allies with a wealth of research-driven resources. We have 2 separate series. So one is the Market Spotlight series, which is a series of 4 yearly events held around the state that each focus on a different global market. Events feature market overviews, a panel of businesses who share their own experiences and best practices for the market, and provide opportunities for networking. We also have a series of educational webinars, which are each held on different international business topics. So to start, I'm going to give a bit of an introduction for each of our speakers. So Jaron Bass is an international trade specialist with the International Trade Administration, ITA's Office of Transportation and Machinery. OTM's objective is to support the U.S. industrial base by developing and recommending U.S. policy positions for multilateral and bilateral discussions that ensure U.S. companies are safeguarded from unfair trading practices, providing information, trade data, and industry analysis to the U.S. business community, policymakers, and trade negotiators, maintaining close liaison with U.S. firms to focus and construct programs that enhance U.S. industry's competitiveness, and providing export assistance, including advocacy and business counseling to help companies penetrate new markets, increase market share, and resolve specific market obstacles. In the OTM, Jaron manages the development of ITA's advanced manufacturing portfolio, which includes robotics, additive manufacturing, advanced materials, and related digital services. Next, I would like to introduce Dr. Xiaoming Liao. Dr. Xiaoming Liao is a distinguished MSU Foundation professor and Anil and Nandita Jain Endowed Professor at the Department of Computer Science and Engineering. He received his PhD from Carnegie Mellon in 2004, and before joining MSU, worked as a research scientist at General Electric doing global research. Since starting at MSU in 2012, he has helped develop a strong computer science program, leading to a national ranking in the top 15. His work centers on computer vision, machine learning, and biometrics, especially on face-related analysis and 3D vision. Dr. Liao has helped chair numerous conferences, has authored more than 200 scientific publications, and has filed 35 U.S. patents. His work has been cited more than 20,000 times, and his research has been widely reported in prominent national and international news outlets, including the Wall Street Journal, CNBC, CNET, Engadget, Fortune, the Mac Observer, MSU Today, New Scientist, Silicon Angel, Angle, VentureBeat, and The Verge. Next, I would like to introduce Pavan Muzamdar. Pavan Muzamdar is the Chief Operating Officer of Automation Alley, Michigan's Industry 4.0 Knowledge Center. Blending his 20-plus years of experience in executive leadership roles with his love of financial analysis and entrepreneurial endeavors, Pavan brings a people-focused, fundamentals-based analytical approach to his work. Pavan is an Industry 4.0 expert who is often invited to speak at conferences and is a regular participant in panel discussions related to digital transformation. Pavan has been instrumental to the success of Automation Alley's Industry 4.0 programs and services, including taking a leading role in the creation and management for Project Diamond, Automation Alley's 3D printing network. In addition to his role at Automation Alley, Pavan is also the founder of PCS Insight LLC, a company that teaches leaders of growing companies how to increase profits by intensifying happiness and reducing friction in the workplace, resulting in greater productivity and long-term success. Pavan is also the author of the book Venture Perfect, the Leadership System to Maximize Teamwork and Profit in Your Business. He is a CFA charter holder and has master's degrees in electrical engineering and computer science from the University of Massachusetts and a bachelor's degree in electronics engineering from the University of Bombay. And lastly, I am delighted to introduce Charles Elwood. Charles is a renowned TEDx speaker and a Microsoft AI MVP with expertise in AI for manufacturers. As the founder of Solismatica and My Audio Bank, he has been at the forefront of leveraging AI and machine learning technologies to drive innovation in various industries. With a focus on empowering businesses through AI, Charles has helped companies optimize their operations, enhance customer experiences, and gain a competitive edge. His passion for AI and its potential to transform industries has made him a sought-after speaker and thought leader in the field. Charles holds a strong commitment to diversity and is certified as a minority business owner. And with that, I am delighted to pass over to Jaron Bass, who will give our first presentation today.
Hopefully everyone can hear me. So I'm Jaron Bass. It was a great introduction, Hannah. Thank you. I'm with the International Trade Administration, as Hannah mentioned. We're a bureau of the U.S. Department of Commerce. So my main organization's mission is engaging in commercial diplomacy to support U.S. industry competitiveness, essentially, at the end of the day. We do this by advocating for U.S. companies through export promotion, informing trade policy, and working with other countries to explore collaboration or making sure that they're staying good on their part of the trade negotiations or trade agreements. I'm based out of our headquarters in DC, though I'm currently in San Diego attending a trade show. So I apologize for any bleary eyes or slurred sentences. I'm still caffeinating, but it should hit soon. It should be good. I serve as ITA's advanced manufacturing lead, and I work on those topics that Hannah had already mentioned before. But since my work centers around trade and more specifically U.S. export promotion, this is going to be my central theme for the day, and I just wanted to touch on some of these industries and technologies and manufacturing that we cover that we feel are particularly impacted by AI and machine learning, and where we see international business opportunities for U.S. companies in this space. So I'm going to start at very much a 40,000-foot view and touch on some of the more focused industries moving forward. So I should say that we should take all of these fun facts and figures that I'm going to show you with a grain of salt. We're limited to publicly available trade data for most part and some industry reports. But for advanced manufacturing technologies, these horizontal enabling technologies, we truly lack good data. And I would love to tell you about trade flows of AI and machine learning technologies. We just simply don't have this information, at least at the public aggregate level. But it's the best we've got. Combined with industry numbers, we can use them as proxies to give us our best guess for what these ideal markets would be for U.S. companies. So you're going to see here a graph on manufacturing equipment trade generally. This is a ton of equipment that's included in this really big bucket. But I think the important thing to note from this slide is the fact that the world's changing a bit. And traditionally, China for years has been our largest source of imports. That we see last year in 2023, Mexico edges out China as our largest source of manufacturing equipment imports. To what degree China is involved in that, we're trying to unpack that too, but again, limited trade data, right? Our top export markets by volume are neighbors in North America, which might not surprise too many, followed by China, Germany, Japan. One disclaimer here too, if we were to look at EU as one market, it would easily be our third place export market in terms of volume. All right. So I have a limited amount of time today. So as I mentioned before, I wanted to touch on some industries that my colleagues and I work on that come up in conversation adjacent to AI and machine learning quite often. This is by no means an exhaustive list. AI and machine learning have roles to play, excuse me, in so many industry verticals. Keeping a lens to inside the factory, though, here are some heavy hitters I'm going to talk about. So again, I'm going to start with digital services because this impacts everything. And if you don't really have advanced manufacturing if you're not digitally enabled. The real big bummer here is that there's just no good trade data for this. The industries I've spoken to, they're highly impacted or simply reliant upon digital technologies and services to really operate efficiently or effectively. We do know we're the world's leader in the digital realm, but we have problems measuring the flow of digital services relating specifically to industrial machinery or manufacturing more broadly. So what you're seeing here is essentially what we have to go with. Anything that's going to be manufacturing specific will likely be housed in these categories, especially in cloud computing, storage services, or my favorite category, other, which is just a small part of the pie, and where all these technologies that don't have a home go to live. So we obviously think the number is bigger than this, and we're just going to have to wait for better data that hopefully gets collected in the near future. What we do know is that where manufacturing equipment goes, so do the services. Oftentimes, the software, the subscriptions, platforms, you name it, they're the value add for machinery purchases, and sometimes they're the selling point. As manufacturing advances, lack of a better word, the need for digital services is going to grow. So this trend is only going to amplify. There's a lot of trade barriers. A lot of times they're opaque, they're new, particularly with digital services. And we kind of stumble upon them in real time with companies. So we rely on our close relationships with industry to figure these out. I've listed some indicators of what we look for when we're determining a country as a good one to target for digital services in manufacturing. This is not an exhaustive list. Again, it's in a nutshell what we look for. How much emphasis is placed in the country for ideal market conditions. How much a country invests in workforce development, how much it invests in its own manufacturing sector and advanced manufacturing technologies. And this is the same with automation. There's labor scarcity, particularly in skilled labor. This is probably a good area for these digital services. So it solves those problems, right? So as you can see, big exports in terms of volume. Go to Canada, Germany, Japan. However, if we want to see where the numbers are going specific to manufacturing, this graph is going to look a bit different. In terms of markets of opportunity, North America is the natural place to consider, as is the case with a lot of these technologies. But there's also the EU, not just Germany, Turkey, Indonesia, Thailand, Vietnam, other countries with burgeoning manufacturing bases are also markets to keep in mind, even though they may not make it in the top 10 in terms of value or volume. And we also obviously discourage U.S. companies from selling digital services in places that may see increased IP theft. I don't think I need to, name names, but I think we all know what I'm talking about. Moving on, industrial automation. So I think fitting segue from digital services because automation is so heavily impacted by them, increasingly so with AI, machine learning. So if we look at automation trade from a high level, these are just the physical goods, so not including any digital services. We see Mexico and Canada, they're our top two export markets by a large margin, and with very healthy growth. Other top markets are very small in comparison, but they're seeing still modest growth. And if you were to zoom in on those individual markets, it wouldn't be as dwarfed by North American neighbors. So here's how we've bucketed this equipment in case you're curious, it's in the four main categories: things to measure things, essentially, electric motors, switchgear, industrial relays. These are among the base level things you'll need to begin automating a process as kind of your backbone equipment. So as you can see here, following the theme of the last slide, Mexico has the lion's share of our exports, followed by Canada. And the shares start looking pretty similar, remembering again that EU itself is a huge market. I want to talk about sensors and sensing equipment. You can't have automation without good sensors, obviously. Sensors become more ubiquitous, they're becoming more sophisticated, perhaps more importantly, cost effective. We see a widening array of applications that manufacturers begin to use them in. They're really an important element to just about any of these categories I'm going to talk about. Again, not surprisingly, Mexico and Canada are best markets. I'm not going to read the product categories here unless you can't see them. Hopefully the font's big enough. Just let me know. This is how we've divvied it up, with my favorite other category being our largest category. Wish I could tell you what all would fit in there specifically. It happens more often than I would like. But another great point for improved data collection. Outside of everything under the sun category, there we've got instruments for measuring the flow of liquids and gases. There will be our number 2 and 3 export category, followed by those sensors associated with measuring pressure. So, like, you can't talk about the digital realm you can't talk about automation without mentioning the digital realm. You can't really mention automation without talking about robotics, and vice versa. Robotics, given its own role in addressing scarce labor, increased demand for production speed, bridging the gap with volatile supply chains. This also does not have robust trade data around it. So we typically look at a couple of industry reports to get our best guess of what's going on globally. For the trade data we collect, the equipment exports are valued at just under 500 million, but we know it's way bigger. It's way more than that. Depending on what report you're looking at, the robotics market value has estimates from between 30 billion to 72 billion. But anyway, from the trade numbers perspective, what we're reduced to is industry reports. But we do know is that the market expanded a lot in 2022, the latest year we have data. Then we measure it by installations, aka sales. China's growth has absolutely exploded in this space. To give you an idea of how much it's grown, China accounted for about 12% of annual installations in 2012. 10 years later, it was 52% of global installations. We see some uptick too in Singapore and in other countries, but kind of dwarfed by China's outsized influence in the space. Another industry that's increasingly impacted by the capabilities of AI, we have material handling equipment. Think of your Amazon warehouses, your UPS facilities, all those things that face growing demands and complex supply chains. Broader categories take up this equipment: industrial trucks, cranes, hoists, pulleys, and conveying equipment. By far the largest category by trade volume is going to be in industrial trucks. So all of your forklifts, your palletizers, AGVs, autonomous mobile robots probably would fit into this category. And other things I probably haven't learned about yet. Altogether, we're looking at over 5 billion in exports, and that's just the equipment. So over 2 billion and $1 billion of this equipment respectively go to Canada and Mexico. Top markets in Europe include the UK, Netherlands, Belgium, and Germany. So think logistics when we're thinking about these markets in the EU. A major component of European economies, particularly distribution hubs in Netherlands and Belgium, would be logistics services that account for a lot of the projected growth in this industry. Major ocean freight and distribution hubs also rank among the top markets for U.S. exports, including Australia, Hong Kong, Singapore. And then you got agricultural and mining economies in Asia Pacific also contributing to these export numbers. Increasingly impacted in largely positive ways by AI and machine learning are the capabilities, the ease of use, and verifiable applications for additive manufacturing or 3D printing. And this goes across industries, obviously. Additive is at a bit of an inflection point. So the hype curve has kind of lost a lot of its buzz, and it's kind of given way to solidifying applications. So what's it actually useful for? It's useful for a lot, but it's usually pretty specific. The clear benefits, depending on what applications, it can include anything from lightweighting, especially for aerospace, rapid prototyping, complex mold building, part consolidation, on-demand, small batch production. And increasingly, we're able to print out a widening array of materials as well, such as composites, ceramics, even bamboo. If you have any postmodern furniture aficionados out there, might be excited about that. But the fastest industries of growth from 2023 were government and military applications mainly. Many governments around the globe have zeroed in on additive as a tool to alleviate supply chain disruptions. Outside of that, medical and dental have seen a lot of growth, and that's driven by additive's ability to hyper customize and build exact and complex shapes. So I can talk about all sorts of different industry verticals and probably bore you, but I do want to mention before I stop presenting the resources that, at least in my world, that we have. That's something to consider if you're a U.S. exporter or looking to develop a technology and make it make sense in your production line. First and foremost, this is my world, right? Export promotion. You should get in contact with your local commercial specialists. They're always a good contact to have, regardless if you need them now or if you need them years from now when you're export ready. Their job is to help you connect to overseas markets, and you can find your nearest specialist on trade.gov, which I have here up on the slide. In terms of resources resulting from public-private collaborations, if you haven't heard about it, many of you maybe already have. Manufacturing USA is a pretty remarkable program. Started in 2014 to secure U.S. global leadership in manufacturing. And it coordinates work across 17 different institutes now. I believe it's 16 or 17. Each with their technologies of focus. They work with industry, academia, and other stakeholders to test applications of new technology, create new products, reduce cost and risk, especially for SMEs, and enable upskilling in manufacturing workforce. If you're a small company, and small is pretty liberally defined by the SBA, is being up to 500 people. The Manufacturing Extension Partnership is a pretty fantastic resource as well, or the MEP. If you're not familiar with MEP, it's a national network, usually run through local universities. It's across every state, including Puerto Rico. And it provides companies with services and access to public and private resources to enhance growth, improve productivity, reduce costs, all that good stuff. And then we've got state level resources. And so I may not have to say this to many of you here, but a lot of these resources are in your backyard. Our commercial specialists, I mentioned, often work very closely with state economic development offices. Many of you are probably familiar with MEDC. We've worked wonderfully with them over the years, as well as Automation Alley. So I'd like to give them a shout out since we are being hosted by Michigan, after all. There are other state programs, though, that offer export assistance across the country, and particularly for small businesses. Last thing I want to mention is the MDCP program. ITA has some partnerships with some key trade associations, one of which is called the Market Development Cooperator Program. It exists to work with industry in efforts to boost U.S. competitiveness across the globe. So the projects differ depending on what partnership you've penned up, but many of them feature export promotion work streams, and they can oftentimes offer benefits to member companies that get involved. Please note, these are the resources I know of in my world. There's a whole lot going on across the government, so I encourage you to research opportunities across different agencies, particularly if you're already working with them. With that, I'm going to stop talking at you, and I'm not sure how much time we have left over for any questions, but feel free.
We do have one question that just popped into the Q&A. They are wondering if there are any specific trade shows that you might recommend for companies in the space.
Oof, there's a lot of different trade shows. That's a good question. It really depends on what technology, what industry sector you're looking to focus in on. If we're talking in terms of, sticking with the theme AI, machine learning, in manufacturing, there's some obvious big hitters. There's Hannover Messe, which takes place in Hanover, Germany, usually every April. That's something to consider. It's expensive though. Another one, maybe more of a natural first step consideration for a lot of companies in the US would be IMTS. That's actually going on this week in Chicago. This happens every 2 years. And then there's a lot of different smaller shows. I'll be heading off to Industrial Transformation in Mexico, for example. This is an offshoot of Hannover Messe, smaller regional show. If you're looking for engagement in additive manufacturing, Formnext, that's a great one to go to. That's in Germany in November. They also are bringing Formnext USA for the first time ever next year. I think it's around the same time. No, it's in May, spring. Apologies. And then for robotics and automation, Automate's an amazing show. It used to take place every other year. Now it takes place every year, and it's smaller than like your shows like Hanover Messe, but it's less overwhelming. It's kind of encapsulates that industry, the automation robotics industry, a little more perfectly, and that will take place in Detroit next year in May, and subsequent years is going to be in Chicago. Demand has basically grown them out of Detroit. Those are some I can think of off the top of my head. There's plenty others.
And then we do have one other question asking when you expect data to arrive on digital trade.
Yeah, I don't have an expectation. I just, constantly hope. Unfortunately, I don't have a good timeline on that. It's something that comes up a lot, especially in discussions with census, but it takes a long time to set up the infrastructure to get good data, and a lot of that is asking the right questions to industry. And the way we do that is working with census to send out, mandatory surveys to manufacturers, which is, the last thing you really want to do is be handed a packet of 100 questions about what you're doing on top of everything else that's already going on in your day-to-day. So you have to be very careful, and the process is, as you could probably imagine, a bit bureaucratic and slow moving. But we hope to get it's slowly improving. We've got harmonized tariff schedule codes for additive. We'll have to wait for a few years for really to do any sort of trade analysis on it, but it's slow moving, but it's happening. So I think we're waking up to the fact that we really need this data. But it's just the way we're set up. We're always going to be about 5 years behind the curve, at least.
Got it. All right. Well, thank you so much for your presentation. And yeah, I'd like to go ahead and move on to our second speaker, Dr. Liu.
Okay, let me share my slides. And are you seeing the full screen?
Yes.
Okay, great. Good morning, everyone. So today, I'd like to talk about AI research at Michigan State University. Yeah, thanks for the organizer for inviting me to have this opportunity. So to begin with, let's talk about what is AI, artificial intelligence. So in general, we consider AI is a broader area that including multiple sort of sub areas, right? Including, for example, computer vision is mostly focused on visual content analysis. For example, you have imager or videos or 3D point cloud. We develop algorithm to understand visual content. That's computer vision. You also have natural language processing, which will be, develop algorithm to understand the text. You have a long text. You want to understand the meaning of the text. That's NLP, natural language processing. You also have machine learning. That's, pretty fundamental for a lot of AI because behind the visual content or text analysis, it's all about the learning algorithms, right? Because we are, away from traditional kind of rule-based algorithm. Most of right now the algorithm is all about machine learning. So machine learning become a core area in AI. We also have pattern recognition, which is an area quite similar to machine learning, but it's more focused on recognition, object recognition, a behavior recognition, and so on and so forth. That's pattern recognition. And we also have biometrics. Biometric is kind of a subfield, is in the intersection of pattern recognition and computer vision, is more focused on recognizing people, people's behavior, recognize who you are from your facial, from your gait, from your walking patterns, for example. Okay. So with this multiple area of artificial intelligence, the area MSU is fairly strong, and also the area I'm working on is called computer vision. It's one of the major area in AI. The goal of computer vision is trying to enable computer to understand the visual content, including imager, video, and a 3D point cloud. Right. So here I'm giving one example. Suppose I have a camera installed on my windshield. The camera is looking out. So on the right-hand side, you see an image captured by the camera. Okay. So once the image is being fed into a computer, now we have AI algorithm running on the computer. The AI algorithm will be processing the incoming image. With that processing, we hope to answer questions such as what is in the scene? How many cars are there in the scene, right? How far away is a car ahead of me? How far away is a curb, right? How fast is the car driving? Is there any pedestrian across the road? So these questions are important to be answered, right? We like to answer those questions. And the computer vision algorithm or AI algorithm essentially is trying to answer those questions. As you can imagine, be able to answer those questions is crucial for automation, especially for autonomous driving, because this question is what, we as a human driver, we oftentimes, answer those questions while we're driving, basically. So computer vision at MSU has a long history. Actually, since Professor Jen joining in the department in 1974, we had about 50 years, at least 50 years of history working on computer vision areas. Right now, we have 6 faculty working on this particular topic. And we also have a past faculty such as Professor Stockman and Dr. Wing and so on and so forth. And we work on, both fundamental research as well as kind of apply the topics in computer vision. And oftentimes the funding source coming from government, such as we had a few big win from ARPA, and each of project costs about 10 to 15 million kind of US dollars. These are the older program as well as BRIA program. But we also work with a company quite often as well. I myself working with Meta, Google, and GM, Ford, as well as some other company as well. So we had a history of working with different sort of partners. And in summary, MSU is a pretty go-to place for computing expertise. So this is the one statistic in the website called csranking.com. It basically trying to ranking computer science program across United States as well as international. If we look at AI field, in particular computer vision, MSU is highly ranked. In the past 5 years, ranking MSU is number 15. If you look at past 10 years, we're number 17. So our friends UFM is number 12, as you can see in this list. So computer vision as a field in AI, it has a lot of different applications. Just for example, the basic task we do in computer vision is object detection, segmentation, and classification, right? As you can see in the top left corner, we detect objects, we understand the boundary of the objects, and we also can make a classification, understand what are we seeing, different semantic category, people, animal, dogs, and so on and so forth. In medical domain, computer vision used to can perform basically, organ segmentation and abnormal detection, right? From X-ray, CT, and MR scans, you want to understand whether there's any, potential disease from those scans, and computer vision can essentially help on that. And for 3D computer vision, as you can see in the left of the middle row, computer vision can help to do 3D reconstruction, right? If you have a drone fly through a building, now we can build a three-dimensional structure of the buildings. So I have a friend from your UC, he has a company essentially trying to looking for any a building structure that's deviate from the blueprint, for example. And this kind of fly through the building can be done once every week or once every few days. So this could be useful for a lot of the industry kind of construction jobs. Right now, when you look at a lot of NBC sports, you see visualization of the sports event has been quite popular. For example, in football player, you have a line drawing on the field, right? In swimming, you also have some visual additive on the videos as well. All of those technique is essentially done through computer visions. Okay. And facial analysis, as you can see on the middle row, of course, does a lot of things such as recognizing people in Asian countries, especially China. People use face to make payments, basically. In the bottom, we see example in fingerprint recognition. This is the expertise of Professor Chen. So he's been working on this for many years. And we also see example of AR VR. That is, you can take a video sequence of your house. We can do three-dimensional reconstruction of the furnitures in the house, so that you can figure out what if I buy a new table, a new sofa, how would sofa will look like in my house. So that kind of AR VR application is possible right now. And of course, Amazon is pushing for Amazon Go. That's kind of the you can go shopping without actually the checking out process. You can grab and go. And autonomous driving, of course, relying a lot of the computer vision technology, because we need to be able to train the machine to be able to see the surrounding and understand the surrounding environment. Okay, so with that, let me kind of dive into a few particular areas that's currently being done in Michigan State. So just give you a flavor about some of the research topic we are doing that has some relevance to manufacture, hopefully. Okay, so one of the first topic my lab has been working on is called abnormal detection. Now in manufacturing, you produce a lot of parts, right? When you produce a part, it's important to inspect the parts to make sure there's no any defects, right? All the parts are normal. There's no any defect happening for the parts. So this can be done through so-called industry inspections. Okay, so this is a kind of a fairly classic topic in computer vision. Even back I was working at GE aircraft produce a lot of aircraft engine parts. So the system was started to develop, even in 1980s, trying to do inspection for those aircraft parts. But nowadays, because we have advanced machine learning, advanced deep learning, so those abnormal detection or defect detection can be done in a much advanced or accurate fashion. Yeah. So in this particular work, for example, we only need a few normal images as training samples, right? So 3 or 4 images can be the training example. So we call this as few shot learning, okay? Once you have this few example, you basically learn model which understand what are the normal or normal object look like, okay? And then during the testing time, if you give me a query image, either normal or abnormal, we can feed this image into my model, and it will produce 2 outputs. Number one, it will tell you whether it's normal or abnormal. So kind of binary classification, right? Secondly, it can also generate a mask, which is the image, binary image. Basically, it tells you that which local area is actually abnormal. It's kind of the masking, tell you, what are the basis, what are the reasons we consider this as abnormal. Okay, so you can see this is quite useful. Normally, this inference or the testing time only take less than a second to do it. It's very efficient. And even more than that, because the parts I want to inspect can be, hundreds or even thousands of parts. So therefore, the model is trained in a way that even though in the training you only see, let's say, 100 parts, during testing time, you can actually inspect more than 100 parts. In other words, you can handle unseen parts. That's, you have never seen before in your training process. You can also handle those cases. So this makes the model to be very generalizable. Basically, you're not limited to the samples, to the categories you have seen in your training process. Okay, so that's one example. And second example is we do kind of three-dimensional scene understanding. So this is important for robotics, right? Suppose I have a robot moving around in the factory, and there's also other surrounding object or maybe other robots moving around, and I want to understand what's going on in the surrounding environment. So in this case, we are showing example with sort of car driving on the street. So you can see that on the top left corner, I'm showing you what is my current speed of my movement because the camera is also moving, right? So camera has certain moving speed. So we're estimating the camera movement in terms of mile per hour. So right now the car stops, so therefore it's almost zero. But whenever the car starts to move, you can see we're moving at 10, 12, 13 miles per hour, okay? In the meantime, for every object, we are detecting them as 3D bounding boxes. And we have a number on top of the box that actually indicates the estimated moving speed for those moving objects, for moving cars. And you can see that this is estimated to be about 20, 21, mile per hour. On the right-hand side, we have this so-called the bird eye view. Basically, it's a top-down view of the surrounding environment. You can see that every box is basically detected and tracked over time because they have constant color of the boxes, right? It's all red, purple, so on and so forth. Because we're doing detection and tracking, therefore we can also predict into the future. We can estimate, in the future frames, where would be the position of those objects. So therefore, you can see the detection, tracking, and the forecasting ability is all integrated into a single system. So this could be quite useful for the robotics environment. You can see this long tail is basically the tracking history from the past. Okay, so in addition to three-dimensional object detection, we can also do 3D surface reconstruction. So in this example, giving a single photo, we actually reconstruct its surfaces. So this surface have geometry information. You can understand what's a curvature, what's a surface. You can also turn this 360 degree because we construct the entire surface of the object. So this can be done for cars, for furniture, so it can be done for a wide variety of objects, basically. And furthermore, there's also a lot of research going on. It's called structural motion. The basic idea is that let's say you use your cell phone or the robot takes video sequences of the surrounding environment. Given this video as input, we can estimate, number one, what is the trajectory of the camera? So what's the camera movement? That's basically this red curve you see on the right-hand side. In addition, we can also reconstruct the surrounding environment in terms of structures. For example, what is the depth of the stairs, how far away is the stair from my camera, so on and so forth. So all the 3D structure can be reconstructed from this structural motion. And finally, we also work quite a lot on biometrics. Basically, people understand people behavior, right? In this project, you can see that, by the way, this is the project sponsored by ARPA for 4 years. We're in the year 3 of the project. The goal of the project is trying to say that if I have a people, as far away, as far as, let's say, 800 meters or even 1,000 meters, can I recognize him? Can I recognize him as one of the people in my gallery? My gallery can have, 500 or even 1,000 people. So it's a many to one matching process. Yeah. So you can see that given the sequences, even though it's quite further away, I see the side view of the face, we can actually recognize him as a top candidate. in my gallery list. And this recognition is using facial appearance as well as the body shape and the walking patterns. So also information are being utilized in the recognition process. I'm also like to introduce some of the work from my colleagues. For example, this slide, this is the work from my colleague, Professor Kong Yu. His lab is called Action Lab. So here's a few interesting projects relevant to manufacture. One of them is that AIGC or generative AI is quite popular, but how to control the generative AI so that the generative video can be more controllable? That's an interesting issue. So in this project, what he want to do is that he want to generate the in-context instructional videos so that those videos can show people and the people can follow the instruction to do certain things, right? And so this is can be generated from the text instruction. So you write a text, for example, moving the mouse and the brush closer to each other. That's a simple text instructions, right? With that text instruction, his model can actually generate video sequences so that whoever being trained can look at video, do the similar actions, right? So this could be very useful for workforce training and even training the robotics, for example. Yeah. And once you have the training videos, people can follow the video to do certain actions, but you also want to monitor people's movement to make sure there's any mistake, right? So therefore, detecting and recognizing any possible mistakes from the people's video become very important, right? For example, sometimes people can skip certain steps, people can pick up or putting in the wrong object. Those mistakes should be detected. Yeah. Professor Kong is actually already working with Dr. Chang, who's a professor in College of Human Medicine, in detecting medical student mistakes, because medical students will often follow steps. So this could be quite useful. And finally, in sort of human-robot interactions, oftentimes you want to predict what's the movement of the human, right? So in this case, his algorithm can actually predict the future 3D hand trajectory, basically how the human hand will be moving in the future. So you can see that the input for the system is a past trajectory, is what has seen in the past, and the prediction will be into the future. And this can be done from the egocentric videos. So this could be very useful for human-robot interactions. He also has a demo in the link. So if you're interested, you can look more from the demo. And also, I have my colleague, Professor Gahasami. So he's a PI for the Human Augmentation and Artificial Intelligence Lab, where the team basically developing predictive modeling technique, especially designed for noisy and data-hungry kind of environment, right? So those kind of noisy tolerant models have been successfully applied in healthcare clinical settings. Where the margin of error is almost have to be close to zero because it's oftentimes a life or death consequence, right? In manufacturing, similar tolerance for noise is crucial for, let's say, predicting equipment failures, right? So therefore, this model can be adapted for predicting machinery breakdown by analyzing the real-time sensory data so that we can reducing the downtime and improving the efficiency. Right. So this is the kind of his main expertise. We also have Professor Sijia Liu, whose area is more in machine learning side of things. So he work on foundational sort of machine learning topics, such as how to do optimization in deep learning models, right? How to combine machine learning with game theory. Okay. He also working on kind of user-inspired research, such as how to improve the efficiency or do safety alignment for larger language models. This has to do with natural language understanding. And for generative AI, oftentimes AI model will generate data with certain bias. So we want to reduce those bias. That's also one of his key kind of research topic. Okay, with that, I want to summarize with this webpage called Michigan State University AI Research. So you can actually visit this webpage. You can see the list of all AI faculties in Michigan State, especially in our college. And everyone kind of have different focus on machine learning, computer vision, NLP. So if you're interested in collaborate or working with any of faculty, I think this is a good kind of starting point for you to get to know people and start the chatting process. All right, that's it. Thanks.
Thank you so much. And I do just have one quick question, which is, so let's say you are, a small, medium company, and, you are interested in maybe working together and researching new technology applications. Is there someone specific they can reach out to, or is that something that you guys do?
Sure. I think there's two potential paths you could start the process. One is, you go to this website. If you're looking for vision, you're looking for computer vision faculty. If you're looking for text processing, you're looking for NLP people. You can reach out to the professor directly. That's one. Okay. Second option is that we have this Michigan Technology, MSU Technology, who are basically bridging the gap between MSU faculty versus industries. So they can be the gate person, basically. You can reach out to MSUT and tell them, okay, here's what I need, right? Who might be the best suitable professor, I can talk to. And then they know a lot of people in our department, in our college. So they will know that, please talk to Professor A, Professor B, and so on and so forth. That's a second pass.
Perfect. Thank you so much.
Sure.
And thank you for the excellent presentation. So with that, I'd like to go ahead and move on to our third speaker, Pavan.
Thank you, Hannah. I'll go ahead and share my screen. Let me know if you can see it. Is that on? Great, thanks. So thanks so much for the opportunity and for that awesome introduction. Really great content today. So my presentation is about AI and machine learning. In our organization, Automation Alley, we're the Industry 4.0 Knowledge Center. So we really look at what does this all mean for an organization. And so as the Industry 4.0 Knowledge Center, our core focus is to help small businesses essentially understand what technology disruption can mean for them. We do that with our 3 brands, and Automation Alley is our thought leadership and regional agency brand. We have Project Diamond, which is our 3D printing effort, and then the U.S. Center for Advanced Manufacturing actually works with larger organizations across the country to provide some of that thought leadership. So whenever I'm asked for to talk about any topic, you can kind of lean in on some of the information that you have, but as AI has become ubiquitous and knowledge has become ubiquitous, the challenge for anybody to talk about any particular topic is that you can just ask ChatGPT, hey, tell me what's happening with AI in manufacturing, and sometimes it's very difficult to kind of answer that question, right? So my challenge today is to give you information that is different from what you can just get on your own. And so with that, the 3 objectives that I have for today are to share some insights and observations, offer some practical ideas, and then point some resources for deeper learning, because we can't cover a whole lot today. So hopefully that'll kind of set us up for a good conversation. The first thing that I want to talk about is, when we talk about artificial intelligence, why is this suddenly become a big topic? Why is the world freaking out? And we kind of put this thing together. We said, if you take a look at technological advancement, it starts with something that nobody pays attention to, then it becomes cute, then becomes interesting, and it's cool. Now you got my attention. It's awesome, amazing. And then at some point, everything that we do with traditional technology, we still have understanding, that there's comprehension. But then at some point, when it goes beyond comprehension, it looks magical, right? And when we look at any kind of technology, there's always good uses and bad uses, right? So that's typically kind of like how technology enhances the technology works. When we talk about traditional technology, it tends to kind of grow slowly. We have time to respond to it. We can put in policies and things like that in place so that the potential uses are more on the desirable side, not necessarily on the undesirable side. And we are even some of the most complex technology, we can understand them. The problem with AI is that it's just going so fast, and in some cases, it's exceeding our comprehension. And it's not just lay people like us, but even researchers in the field are kind of at odds trying to explain why AI answered questions a certain way that it did. And this is causing a sort of a great, existential kind of questioning of what are we going to do with this technology. So, some examples. Wharton University, the Wharton School at the University of Pennsylvania, they challenged ChatGPT and its MBA students to create some market feasible ideas. And then of the 40 exceptional ideas that were presented, ChatGPT authored 35. So there's a data point, right? A lawyer used ChatGPT, and the response that he got was that it completely faked up some cases. It was then sent to the opposing counsel that couldn't find any of these sites. Jeffrey Hinton, who's kind of the father of AI, invented or developed the backpropagation algorithm for neural networks, left Google so he could freely talk about the dangers of AI. And then there's this example of a Google engineer who said he was convinced that the AI that he was working with was sentient. Now, why is that? And I think the simplest example that we can come up with is that, we need to understand a little bit about how large language models work. And by the way, this is focused on large language models because the world kind of changed when ChatGPT was unleashed on the world in November of 2022. So that's kind of what I'm going to focus on. But Professor Liu has mentioned there's many, many other applications. So very simply, large language models take a massive amount of training data, and basically think of training data as all human knowledge in text and in symbols. It is sent to something that's called a predictive neural network, which understands sort of how to create these predictive models. And then a response is generated, and then it becomes meaningful based on human feedback. But here's the key concept. Meaning is created in the human mind. And so when you talk about language, we can string together words, but at one point, at some combination, that combination of words makes meaning. And when you keep doing that with massive computing power and memory, you have what comes out to be this magical thing where you say, tell me how this works, and it comes back with something that's cogent and actually quite meaningful. So we've already seen some examples of AI in manufacturing. I'll give a couple. And then really what I want to focus on is, what does this mean from an implication standpoint? So if you look at traditional robotics, a human has to program the robot. Where this is going is that now there's this example of RoboCat, which is a product or a development by Google's DeepMind. The change now is that the robot learns to code itself and can create some new assemblies and then use some of the capabilities of AI to essentially iteratively become better. That's new. We have an example of a company that's actually a member of Automation Alley. It helps workers follow complex directions step by step, verifying each process. So it makes the process side of things much, much more robust. But really, AI is impacting all areas of advanced manufacturing, from additive manufacturing, materials, data, computing, cybersecurity, simulation, robotics, IIoT. In fact, as Professor Liu mentioned, you can now take a 2D picture and create a 3D model. Well, guess what? Once you create the 3D model, you can now take that and give that to a 3D printer after some processing, and you can convert a 2D picture now into a 3D product. And this is how all these technologies are sort of combining with each other. And that is the piece that we need to focus on as an ecosystem, as an industry, is how do we kind of make that something that we are resilient to as we move forward from 100 years of manufacturing excellence to where manufacturing is going. The big implications for traditional manufacturing is capital is becoming flexible. So if you look at a manufacturing facility today, it's primarily dedicated capital. There's a piece of equipment that knows how to do a particular thing. But when you start looking at something like a 3D printer, it becomes more flexible. A 3D printer doesn't know what it's supposed to make. It is waiting for the design, and its software is going to convert that design into a physical product. So if that's true, then process excellence, which is what we value, needs to change to design focus. That is, companies can't just be worried about or or focused on how to do something. They need to understand what it is that they're making. If these two are true, then CapEx or capital expenditures need to really give way to IP, or at least have IP also as part of a company's balance sheet. And then as process becomes more and more automated, we don't need centralized massive plants. We can actually have distributed manufacturing. And those are the implications that we really need to understand as companies to figure out what is our future in manufacturing. So what's a leader to do? And I'd like to kind of talk about this within the context of something called the hedgehog concept. This was popularized by Jim Collins, who wrote Good to Great. And his thesis was that a company needs to define something that is its core focus, that it's passionate about, that it is really good at doing, and it can generate economic value. And then this intersection of these three areas is what we would call our hedgehog. If you have something that's a core focus that you're really good at and love doing, and it can generate economic value or make money doing it, then this is what you're going to be really, really good at. And that's how this is where the source of your economic value is going to be. Now, what happens when that hedgehog is now disrupted by or aided by AI? So we have our traditional hedgehog, and then we have to find the subset of that where if you add the AI component, you have a new hedgehog which is accelerated by AI. And we'll take a look at a couple of examples, but that really is foundationally the issue that manufacturing companies need to really home in on so that they can become relevant and continue to prosper in the world of AI. So some case studies I'd like to share with you, these aren't necessarily manufacturing related, however, they can be contextualized for manufacturing. So we might have heard, people know this, in 1997, Garry Kasparov, the grandmaster in chess, lost to IBM's Deep Blue. But he had an idea. What he said was, what would happen if I took a human and then I also combined them with the ability to use any number of computer algorithms and play chess? What came out of that is something called advanced chess, and in which humans and computers play against humans and computers. What's interesting is the two key findings that we think are essentially where the future of AI and humans really need to be focusing on. So the first thing is, it's not about human against computer, it's human plus computer. The second thing is, the human player has to be really good, not necessarily a grandmaster, but they still need to be a subject matter expert. How do you become a subject matter expert? You play against the computer and you become better. And this is essentially what we believe are the two foundational pillars on which the future of humanity and AI should be. It's about human plus computer, where the AI makes the human better. We have an example of our own. One of the things we do are what we call Industry 4.0 assessments. They are really deep dive analyses into the culture, finance, and technology capabilities of an organization. Initially, the way we would do this is we would ask all our companies to fill out questionnaires, and a human analyst would basically go in through those questions, and we would start looking at cultural and strategic alignment and things like that within the organization. Obviously, that had a limit to how much data a human analyst would be able to manage. And so in 2018, we actually hired a computer science intern to AI enable us using some natural language capabilities. And what it enabled us to do was give that same level of alignment and insight into the organization, but with essentially an unlimited or undefined number of people within the organization, completely scaling up our ability. And at the same time, it gave our analysts superpowers. What was also interesting is that while the analyst was more productive and was able to make great use of this data, when we presented to the organizations, it was only the CEOs of the companies that found the insight valuable, but sometimes the people around the CEOs weren't necessarily quite excited about it and quite enthusiastic about it, because they saw that as a threat to what they basically were able to provide. So it was interesting how this was taken by essentially the consumers of the information. For us at Automation Alley, we encourage every staff member to use ChatGPT and other AI tools, Gemini now, and pretty much anything else, and including open source tools. And we've found that there's a huge amount of benefit in collaboration, creation, content, et cetera. And that is all done within the framework of our ability to collaborate digitally really well. So some really basic practical tips in terms of how you can use this within your own organization. I'll whip through these. Happy to take some in the Q&A. Gen AI is great for synthesis and comparisons, ideation, getting started on a project. Always make sure that you ask AI to give you results in chunks that you can verify. Also, because the AI can be biased, you can actually ask it to argue against itself. You can ask Gemini to argue against ChatGPT and vice versa. And that it's always important to understand that these prompts, results, and all that are generated should be kept confidential. So as long, even though you're working with something, be careful what you're giving it as input. It's much better to anonymize. In terms of don'ts, don't ask for factual information unless you can independently verify it, because AI doesn't really understand. It makes stuff up. So sometimes it might refer to a database that has factual information, but always triangulate what you need to do. AI is great for a start, but sometimes it kind of goes down its own path. So it's not necessarily best at completing a project. It's not going to be culturally or emotionally sensitive. It's human plus AI, so the human has to be the ultimate arbiter of the result quality, and then of course be always conscious of privacy. So if in a manufacturing context, sometimes we feel, well, AI it's all about the new. Well, not necessarily. You can actually use AI and make it useful in existing processes and existing systems. So for example, these are some prompts that we came up with. If we know that, for example, CNC machining is one of those hard to find skills, and if someone has a basic understanding of technology and some simple coding, they can actually pick this up, and AI can actually teach them. So here's a simple prompt. Hey, what's a simple first assignment to teach someone CNC programming? Similarly, if you find someone's CNC code, you can actually say, hey, please explain this code, and paste the code into the LLM, and it'll give you some guidance as to what it's trying to do. Some more kind of policy type stuff. I'm having trouble with my employees not following safety guidelines. What training programs, incentive structures can I put in place? And what that AI is going to do is it's going to go to its massive database of prior knowledge, and it'll come up with something. And some of it might be awesome, and some of it might not be, but it'll start to get you to think. Another great prompt, and I've actually tried this one. It's actually quite fascinating. I'm a CEO of a plastic injection molding manufacturing company, and then insert any traditional technology. What should I be paying attention to? And what are some of the threats, and what are some of the things that are happening outside that I should be paying attention to? And you'll be surprised at how interesting some of these answers are. So what are some first steps? Obviously, get into it, jump into it, learn, experiment, innovate, understand as an organization how to do this. On the other side, it's a double-edged sword. Cybersecurity is going to become even more challenging with things like deep fakes, phishing attacks, and things of that kind. Data is going to be even more sensitive, or being careful about how data is managed is going to be even more important because of how it can be used by AI, etc. And then, like anything else, always start small and iterate. So what are some additional resources? Earlier this year, we actually did a playbook. It's called The Rise of AI. It's a great primer into what's happening. This was about, I'd say, 4 or 5 months old. So some of it already has now been surpassed, and things have changed. And then there's this excellent video. It's called Intro to Large Language Models by Andrej Karpathy. He's actually a coder. And this is designed not necessarily to get too deep into the coding, but if you understand a little bit of technology, a little bit of software, this is a great tool. And then the last one, there's a channel called 3 Blue 1 Brown, which kind of goes into just a little bit about the how, what's happening, how does this actually work? And you don't need to get too deep into it, but it's actually a great resource. And the final thing is, all of what I just said is as of today, because things are changing so quickly. So some of those do's and don'ts might also be different. But hopefully that was a good introduction. And then I'll be happy to take any questions if we have some time.
We are running a little short on time, but if you, for one question, I was just wondering if you could tell us briefly, but just a bit about Project Diamond and some of the work that Automation Alley is doing.
Sure, I'll keep it very short. So Project Diamond was started during the pandemic, and you know, everything we've seen about advanced manufacturing is that we feel that additive manufacturing is going to be one of those technologies that small businesses really need to understand. During the pandemic, Oakland County came to us and they said that they were having trouble sourcing PPE, and they asked us for a transformational project. And we're very well versed with how small businesses think. So we said to Oakland County, they're not going to buy 3D printing, even though they need to understand it. So the simple premise of Project Diamond was, we'll give you a 3D printer and we will let you use it as if it were your own. You get an essential business badge. But if we call upon you, you'll print PPE for us. And that was a very simple premise. So we gave away 300 3D printers, 250 in Oakland County, 250 in Macomb County. And that was really what Project Diamond is. And then our partner at Markforged actually helped us network those printers so that if we did need to send any kind of PPE design, we could send it to all 300 printers. That was the basic premise. We didn't need to do any PPE for the pandemic, but we printed tourniquet clips for Ukraine when we got a request to do that. So we validated the network. Phase 2 has built upon that success and now is taking that emergency response nature of that network to make it more of a commercially viable 3D printed distributed network. So that's in it's a nutshell, you know, the introduction to Project Diamond. You can find a lot more information at projectdiamond.org. And, you know, hopefully it'll be coming statewide at some point, because it was picked by Governor Whitmer as one of the programs to scale up in the rest of the state.
Wonderful. Thank you so much. An excellent presentation. And with that, I'd like to introduce our fourth and final presenter, Charles Elwood.
Right. Let me see if you can hear me?
Yes.
And then I'll try to, you know, webinars are always hard for me. I like to interact with the crowd and the audience. And I do speak with my hands, so my hands are going to go all over the place. But I've already texted Chris Kaminsky, who's on this call. I'm going to ask for audience participation. And Pavan and Xiaomeng, if you could help answer this question, a couple of questions at the beginning too. And Dan Stewart, I saw you're there. So while I'm going to present, I'm going to watch your answer to this question. But I'm always interested in, hey Chris, why are you afraid? Do you have any fears currently of AI? Why you're afraid of AI? And the reason I ask is kind of like what Pavan alluded to is, you know, you can do that to ChatGPT and answer this question and all the things I'm going to probably talk about. But I'm interested in the audience, you know, what are still the fears lingering in people today, right? And Pavan, you can answer live, I guess. Yeah, if you want to answer live.
I'd love to hear what other folks have to say, but we'll give that, and then I'll be happy to answer. Yeah.
Sure. Yeah. So, yeah, Dan says he has no fears. I'm going to start with my fear. When I first started looking at AI, I was the director of project management, and I saw what AI could do very early on. And I said, this will replace my job. What am I here for? So I started learning about it, and you know, I was like, this is incredible. And then now I've given it to my kids, my family. Like, I've accelerated everybody I touch, you know, around me. And, you know, now my fear is letting people get left behind, right? And I'll show some statistics in a slide that the US Census Bureau did. Michigan is not adopting AI probably as fast as some of the other states. So that is actually my concern now, is like, how do we help people get access to this, start using it? Because a lot of fears are keeping people from trying it out. So let me see, I'm going to scroll down, and maybe Hannah, if you can help too. AI CAD a little bit. Yep, I think it'll be just a tool that will adapt to use. Pace of AI. So that is so we'll keep the fears going. I think these are super interesting. Pavan, did you want to add anything yet, or you want to wait?
No, I think that these are all completely understandable, right? And so I think that's why, as I mentioned, without jumping too much into it, I think the future is not human versus AI. We have to collectively figure out how do you make it about human plus AI, and how do you make the AI serve humans to make them better, right? Those are the two questions that we keep thinking about. And Sal Khan from Khan Academy is basically dedicating his life to kind of answering that question. He just wrote a book called Brave New Words that is basically focused on that. And
yeah, no, absolutely. Fear of replacement. And then now that I've used it, I think humans, we can create the rules, right? We can if it says something and we look at it, we can always say, no, that doesn't make sense, or that's unethical. So I think we will always retain control. I think Dan was the one that told me humans are resilient, and I think we're going to build the social constructs. But great stuff. And Dan, you're saying fearful of their jobs, right? Security, as Pavan indicated. I hope to talk a little bit about that, data security. Now that information is training this model, how do we own IP and our own data, right? And then second question, I'm going to pose to the audience, and then I'll get into some of my slides, is so AI has really allowed me to kind of dream and follow my passions and do whatever I want. And the one thing I do now is I clone voices, and just at face value, a lot of people are like, ooh, that's deep fakes. You can empty out my bank account. That's super scary. But what I do as a human augmenting AI is I go to throat cancer patients, ALS patients, cerebral palsy patients, and I say, let me help you clone your voice or how you communicate, and let me help you, interact with the world, get your identity back, and come back into the world, right? It's super powerful in that aspect. So my second question, and then I'll go into my slides, and then I'll monitor the Q&A, is if you have a passion or something that you didn't think was possible a couple of years ago, what is that, right? What do you want to do with this great power and this great amount of knowledge now that could augment your life? So I'll leave it at that. And Dan and Chris, I hope you chime in. Oh, Chris, telling educators like a topic and break it down into weekly lesson plans. I think for education, it's going to have a huge impact. And I'm going to jump into something which is interesting. As University of Michigan, it was about 1.5 years ago, they gave ChatGPT, Azure AI GPT, Llama, and all different, you could even select it, to all their students, all their admin, all their researchers across their campus. And they were like, have at it, learn, augment your learning. I think their belief was in 4 years from now, if you find it, you need to hire a student, you look at University of Michigan, and here's a student that comes out AI digital literate, right? Who are you going to choose? So they're 5 years in front. And I thought that was incredible. The other thing about education is Singapore, they did this about 1.5 years ago, implemented through K through 12. They just, in front of Parliament, said, we want to give access to this to our elderly generations to help them augment their lives too. So Singapore has an incredible head start. They're learning from their population how to interact, how to use AI responsibly, right? So Dan, I'd love to use and have the tool to establish plot outlines for fiction books. And we talk a lot about books, you and I, Dan, and Yuval Noah Harari's new book just came out. I'm in the middle of it. Another great resource on books and AI. And that one is interesting because it talks about government systems and different social constructs like the religion and how information supports those institutions, and how AI can now, layered on top of social constructs that keep people together, how that's going to impact that whole world, right? Interesting stuff. So Hannah, I'm going to jump into the slides, and maybe you can help see if there's more answers. But since I'm an AI MVP with Microsoft, what's interesting is I get to see stuff that's NDA, and they let me use their technology before it becomes public. So it's a struggle for MVPs because we're never sure if we can talk about some of this stuff. So frantically this morning, Hannah, I was searching the web for if Microsoft mentioned any of these things. So everything in my slides today will be like compliant with their rules, but it gives you a glimpse of what I see, of what they see, of where the future is going. So I thought that might be an interesting presentation for manufacturing, for automotive, for Detroit, for our state. Where is this going? And the first thing I saw Marco Castellano started speaking about, he's the VP of AI at Microsoft, is multi-agents. So before ChatGPT were text models, and you put in text and it responds with text. But they are now, and they think the next big thing for next year is what's called multi-agents. And that's really, it's taking action with your data, using AI to think kind of on your behalf, right? So the example he gave, and there's a YouTube video on this, if you search for multi-agents with Marco Castellano, he has AI read a PDF of soccer schedules, I think, for his daughter. And he said he gave AI the power to go into his Outlook and block off those the soccer games in his Outlook calendar. But he said, you know, the important thing is, he said, I didn't allow it to delete any calendar items or any emails. So really, really interesting, because now AI and its logic can start taking actions for you. I know we've all been dreaming of this, you know, I think they called it functions in OpenAI, but inside of Microsoft now, it can take some actions on your behalf. I want to talk a little bit about RAG. You know, that's Microsoft's lingo, but it's really, you know, a lot of people are scared of hallucinations, and, you know, not having like real truthful data. But about probably 8 months ago now, they introduced RAG. And what RAG really is you load documents into a vector database. And that gets technical too, but it's really, you get to talk to your documents in natural language, and it references those documents. So like, it doesn't hallucinate and make up stuff anymore. Like you see in the chart there, PDFs into blob storage, and then the GPT or the AI looks and finds those documents, tells you where the documents are. You can show it, and then it just layers understanding on top of it, right? So you're speaking the truth. And what I've seen, you know, some of my clients use it for is customer service reps. They have to access, you know, all these manuals to answer questions about a product or a product line. You know, they can now talk to all their manuals and then feed that information back to the client that's asking questions. I've also, you know, people use it for production lines. They have a bunch of equipment, a lot of manuals. You can now load it up into a database and just talk to all your manuals at once. It's like, hey, I have this machine, it does this part is broken, what's a replacement part? And it would reference and pull in those documents. So it's grounded in truth, right? Super powerful. And I'll just pause for a second. Any other questions? Oh, Harari's book from Dan. Yeah, that's a good book. And then I'm going to go into more of the future stuff. So a lot of people, you know, we've heard all the stories about sustainability of large language models, and Microsoft is working and actively working to create small language models that are fine-tuned to a specific area, like manufacturing, production, customer service, et cetera. They're much, much smaller. They use less energy, and they can be placed on the edge, which means like your machine, a phone, a car, you can put the model right in the car, so it doesn't need a cloud connection anymore. These are small enough, I've heard people put them on a Raspberry Pi, right? And I heard, you know, Marco say, if you ground the data in something like RAG, you can use these small language models now just to talk to your documents. Like, imagine the possibilities, right? In a car, you gather all this data. You don't want to save all that data. It's meaningless. But now these edge AI models can just extract the value you need and send it to whoever needs to analyze the data, be it the driver or somebody at, you know, the manufacturer at headquarters, say, we need to order these new parts, they're failing everywhere. So super exciting stuff. I want to go into multimodal, and I think this is great for Michigan, for our manufacturing base, because multimodal means it can speak, it can listen, it can see, it can make images, and it can do text input and output, right? And initially, they were all separate models like DALL-E or GPT. They've combined those, like GPT-4o is all these models, and it switches between models so fast. Like you can just create, like kind of like what Pavan said, I want to create this object, and then it could switch over and create an image of the object and maybe the G code. Like it communicates in multi modes. I think the future of this, and you can hear Marco start talking about this too, is other modes of inputs and outputs. So you layer robotics, you add sensors, you know, can you touch, smell, or add actuators on the output side, right? And then you feed that into the model and fine tune and train the model with actual interaction with the world. This hasn't really been done before, but that's the next frontier, and we are well positioned, kind of like you saw in the other slides. Automation, robotics, that's our jam, that's our area, right? So multimodal is coming, and it's going to be incredible. This one is multi-model, which is also very interesting. So if you go into Azure, this is an eyesore, I know, but these are all the different GPT models that you can use inside of Azure. Like Microsoft doesn't say like you need to use GPT-4 or you need to use 5.3. They say we've got Llama, we've got all these things, and you can piece them together. And this chart shows model accuracy. So if one model is more accurate than other, you can have it like the multi-agent thing I was talking about, you can have it perform that task. And then, you know, if you have another task that another model is best suited for inside of Azure, you can have that model perform that task, or have this model check on this model over here. So multi-model, I think, is coming. They have it available in Azure now. But I think it's super exciting, right? So how are we doing on time? 11:27. That leaves 3 minutes for questions.
It's okay if we go over by a few minutes as well.
Okay. So I try to do it fast. Oh, and yeah, can you still see my screen? So I came out of presentation mode. So this is the survey by the U.S. Census Bureau. It's the business, I think, business outlook survey. But you could see here, like the question is, during the next 6 months, you think businesses will use AI in producing goods, right? And you have DC, Colorado, Nevada, Delaware. I looked, you know, you have to scroll down to find Michigan. A lot of these, when the U.S. Census Bureau went and asked all these businesses, are you using AI? Some of these questions, you know, Michigan is still like very low on the list. So that's what I wanted to bring up today is, you know, this is concerning to me. You know, based on what I was saying at the beginning, I use it to accelerate my life, my family, everybody I help, you know, my clients in the manufacturing or people without a voice. But I'm concerned about potentially the state getting behind. So that's one of the things, you know, one of the slides I wanted to show today. And this is on my website too. The U.S. Census Bureau, it's hard to get to the data. So I put it in Power BI and put this on my website. So anybody can go to my website, solismatica.com, and this is featured front and center on my website. So yeah, that was all I had to talk about. I hope, you know, and maybe if people are still in the audience, Dan, you had a question. Can we configure RAG to interact directly with others? So RAG is, you'll layer natural language. Like I have GPT-4 typically on top, or you can use like a small language model too, just to understand my language. And then it goes down the bottom later. They use an AI model called vector embeddings models, and that vectorizes the documents and turns the documents into computer language, really. So, and then the GPT-4 layer just talks to that like mathematical model in the vector database. So you can set it up as an app. Like Microsoft actually makes it pretty easy. You load your documents, you say deploy app, and then you can send the app to anybody, and then now they can chat with all the documents, right? So I think, does that answer your question, Dan? I wish you could. Okay, I got a thumbs up, so maybe he answered it. Yeah, Pavan, you came back on. Did you have some comments or? want to go back to the fear thing, I mean, there's a lot of fear still out there, right?
Yeah, no, this is fascinating stuff. So, you know, I think the fear is, well, this is my personal opinion. I think the fear is a little, you know, it's understandable, but I think we have to get beyond it, right? We have to go beyond it. And just like you said, Charles, you were fearful a little bit and then you jump right into it and you're like, okay, this is not all that scary, you know? And
Yeah,
yeah.
it's
Yeah.
brought, like, I gave it to my 3 boys, right? And I find that, you know, high school is where they start picking up how to use AI.
Mhm.
But he uses it, my son uses it all night as a tutor, and he'll actually prompt it. It's like, don't give me the answer, but I want you to teach me the process. I want you to help me learn something new. And I want you to never give me the answer, right? He's actually teaching this AI to not jump to the conclusion and actually learning to think about how to learn. And I was
And
like,
that to us is exactly where it needs to be. Like our educational system is designed for this QA type model because we had, you know, we had a bandwidth constraint in synthesis of the student response. So we created a model where, you know, we asked for like essays and things like that. And I think we can flip it right on the end and we basically say the AI becomes your Socratic teacher. The AI doesn't give you the answer, but the AI is like asking you the question and you learn, you know, this. And this is Sal, what your son is doing is what Sal Khan kind of conceived with Khanmigo. And Khanmigo is your online, and it'll never give you the answer, but it'll keep prompting you. Well, okay, so well, that makes sense. Well, why just say that? And you know, I think that that's where the future is. It's kind of like in advanced chess. How do you become a better chess player? Well, you keep playing chess against the computer, you know, and at some point it'll, you know, it'll stop kicking your butt as much as it did before. You know?
yeah.
Yeah.
Yeah, I think there's so much opportunity in education. You know, and I've asked my son too, it's like, do you tell kids at school what you're doing, like how you're prompting it to, you know, this Socratic method and not giving you the answer? And he's like, I do. And, you know, a lot of them have parents that tell them, you know, this is cheating, or they have teachers and they kind of laugh at me. He's like, you're cheating, you're going to get caught, you know, and he's trying to help them in a way, but he's kind of backed off from helping others, you know, do it ethically too. He's trying to teach him to do it ethically, but it's the irony is the other students weren't given permission.
Yeah.
So they tell him, it's like, nope, we don't have permission. So we don't think you should use it too. And so he stopped telling other kids, right? It's a cycle. Like, how do we break this cycle? And yeah. So Xiaoming, did you have a comment, or you can?
You're muted.
You're on mute. Yeah.
Sorry, yeah. I think that's a very good point to let the AI tell you the thinking process, right? Step by step, but not jump into the final answers. So we see this in a lot of design actually as well. So people use AI to help you to design new, let's say, pictures and figures to kind of promote your product, right? Oftentimes the picture generated by AI is not directly useful, but at least give you ideas on how to make a new, you know, combination or composition of different things. This kind of idea providing capability is very useful for AI. So I think this is also an example of, you know, Pavan was saying that AI plus human should be working together, kind of doing things better in a better way. I think that's best usage of AI systems.
Yeah, and you know, you're talking about vision. I remember one young teacher said her mother had a disability and they were designing a new house, and GPT-4o had just came out, and she was talking to her mother and designing a room, and then they would visualize it in GPT-4o, right? And she was crossing multi-modes and using it to, you know, interact with her mother and visualize things, right? As humans often do. So I thought that was fascinating. And Pavan, your note across, so you're touching on multimodal in terms of, you know, your comment on we can dream an idea, type it into ChatGPT, creates the G code, and then the robot, you know, that's the mode that Microsoft is envisioning, is then you generate into an action and you actually print that product that was imagined up, right? I think, you know, your work with Project Diamond, I think, is years ahead of things. So yeah, very cool stuff. So
Wonderful. Well, if anyone has any last questions, you can put them in the chat now. We'll give just a minute. Oh, wow. It sounds like, so there's just a comment that there was a lady with an AI-based school called 2 Hour Learning. So yeah, I will look into that. Awesome. All right. Well,
Wonderful.
thank you so much. Oh yeah. Yes, Pavan?
No, I just said wonderful. Thank you.
Yeah, this was fun.
Yeah, this is good.
You have the opportunity. Yes, thanks.
Excellent. Well, thank you to all of our speakers. Thank you to all of our attendees.